Ray Kurzweil, The Singularity is Nearer, When We Merge with AI. In 2005, Kurzweil wrote the seminal book, The Singularity is Near. In the years since, the amount of computing power that one can buy per dollar has increased by 11,200 times. In 2005, smartphones and social media were in their infancy. Today, they're ubiquitous, connecting billions of people worldwide. In the realm of biology, the cost of sequencing a human genome has plummeted by 99.997%. These aren't flukes, but rather manifestations of what Kurzweil calls the law of accelerating returns. This law states that information technologies become exponentially cheaper over time, as each advance makes it easier to design the next iteration. The operation of this law is seen in the fact that, between 1959 and 2023, the amount of computational power one could buy for $1 multiplied by 1.6 trillion. The pace of change is accelerating, and we're entering what Kurzweil calls the sharply steepening part of the exponential curve. In this blink, you'll see why Kurzweil predicts the coming of a singularity, a transformative event in human history in which technological growth becomes uncontrollable and irreversible, leading to unforeseeable changes in human civilization. Let's begin. The path to intelligent machines. From the rudimentary computers of the 1950s to today's AI chatbots, the quest for machine intelligence has been a story of breakthroughs, setbacks, and paradigm shifts. It's a tale of two competing philosophies, technological breakthroughs and looming questions about the nature of cognition. In the 1950s, as computers began to show promise in complex calculations, two schools of thought emerged on how to create machine intelligence. The symbolic approach, championed by researchers like John McCarthy, sought to replicate human reasoning through explicit rules and logic. Picture a massive flowchart dictating how to respond to every possible situation. This method showed early promise in narrow domains, but quickly hit a wall when faced with the nuances of the real world. Meanwhile, the connectionist approach drew inspiration from the human brain itself. Instead of hard-coded rules, it used networks of simple nodes to learn patterns from data. Frank Rosenblatt's perceptron, an early neural network from the 1960s, could recognize basic shapes. Yet it struggled with more complex tasks, leading many to dismiss the approach as a dead end. For decades, AI research oscillated between these two paradigms, making incremental progress but failing to achieve human-like flexibility. The game began to change in the 2010s with the rise of deep learning. By leveraging vast amounts of data and exponentially increasing computational power, researchers created neural networks with many layers, capable of discovering subtle patterns humans might never notice. The results have been nothing short of revolutionary. In 2015, Google's DeepMind shocked the world when AlphaGo defeated the world champion in Go, a game long considered too complex for machines to master. You run 1 kilometer within 8 minutes and 19 seconds. But this was just the beginning. By 2023, AI systems were writing coherent essays, generating photorealistic images from text descriptions, and engaging in open-ended conversations that could fool human judges. Take GPT-3, the chatbot that launched AI into public consciousness. This language model, trained on an enormous corpus of internet text, can write everything from poetry to computer code. It doesn't just regurgitate information. It combines concepts in novel ways, sometimes displaying flashes of creativity that feel eerily human. When computer programmer McKay Wrigley asked GPT-3 to answer a question in the style of psychologist Scott Barry Kaufman, the AI produced an original response that Kaufman himself acknowledged sounded authentic. Yet for all their impressive capabilities, today's AI systems still lack two crucial elements of human cognition: contextual memory and common sense reasoning. Contextual memory allows us to maintain coherence in long conversations or while writing extended documents. Current AI models often lose track of context after a few paragraphs, leading to inconsistencies or non sequiturs in longer outputs. Common sense reasoning, our ability to make inferences about the world based on general knowledge poses an even greater challenge. Humans effortlessly understand that if we drop an egg, it will break, or that children running through a kitchen with muddy shoes will likely annoy their parents. AI, even that which can perform at a PhD level on certain tasks, can sometimes struggle with these kinds of intuitive judgments, often making errors that would be obvious even to a child. These limitations highlight the gap between narrow AI, which excels at specific tasks, and artificial general intelligence, a system with human-like flexibility across all cognitive domains. We aren't there yet. Kurzweil estimates we will arrive at AGI in 2029. What happens when we finally bridge this gap? Kurzweil believes we will begin approaching a pivotal moment known as the Singularity. Once AI systems reach human-level capabilities in areas like programming and scientific research, they will rapidly begin to improve themselves as smarter AIs work to build even smarter AIs, and so on. This is known as an intelligence explosion, a runaway process that could lead to superintelligent AI, minds that surpass human cognitive abilities as drastically as we surpass those of ants. Kurzweil predicts the Singularity will arrive around 2045. This will be a world in which biological and artificial intelligence converges. The distinction between the two will become meaningless as brain-computer interfaces enable us to augment our brains with those of AI, expanding our cognitive abilities by orders of magnitude. The implications of such an event are as profound as they are hard to predict. Would superintelligent AI be benevolent toward humanity? Or might it pursue goals misaligned with our well-being? Could we merge with these intelligences, augmenting our own cognitive capabilities? These questions, once the realm of science fiction, are becoming increasingly relevant as AI capabilities grow. Microscopic marvels. Imagine a future in which you could hold your breath for 4 hours, think 1,000 times faster than you do now, and live for centuries, all while looking as young or old as you choose. These are some of the possibilities suggested by proponents of nanotechnology. As we stand on the cusp of a revolution in medicine and technology, we may experience a transformation that will reshape our understanding of health, aging, and what it means to be human. Today's medicine, despite its marvels, is an imprecise art. Doctors often prescribe treatments that work for most patients, knowing they might not be optimal for everyone. But a paradigm shift is underway. By merging biotechnology with artificial intelligence and digital simulations, medicine may one day become an information technology, one that can benefit from the same exponential progress we've seen in computing. Kurzweil sees this transformation unfolding in 3 phases. The first, already in progress, involves applying our current pharmaceutical and nutritional knowledge more effectively. The second phase, which has just begun, combines biotechnology with AI to accelerate treatment discovery. Imagine designing and testing breakthrough therapies within days using digital simulations, rather than spending years on clinical trials. The third phase, which Kurzweil expects in the 2030s, promises to radically overcome our biological limitations. Nanotechnology, the manipulation of matter at the atomic scale, holds the key to this future. Take molecular assemblers, tabletop devices capable of manufacturing virtually any physical object by arranging atoms precisely. These assemblers could produce everything from food to electronics, potentially at pennies per pound. In this world, the true value of products would lie not in their materials, but in the information they contain, the innovation and design that went into them. The impact of medical nanotechnology will be profound. Envision swarms of nanobots coursing through your bloodstream, repairing damage at the cellular level. These tiny machines could optimize your hormone levels, prevent diseases before they start, and even replace entire organs with superior artificial versions. Cancer would be eradicated cell by cell, with a precision far beyond today's treatments. Your genes could be fine-tuned in real time, preventing the accumulation of errors that lead to aging. The brain, too, would be transformed. Nanobots could repair neural damage and replace non-functioning neurons. They would also enable the brain-computer interfaces that would integrate our minds with vast cloud-based knowledge networks, as well as direct neural control of machines. This merger of biological and digital intelligence could expand our cognitive capabilities in ways we can barely imagine, perhaps allowing us to visualize complex, multidimensional concepts impossible to conceive of today. Such a nanotech revolution would no doubt reshape society. Physical scarcity would likely become a thing of the past, potentially allowing for universal provision of basic needs. However, the pace and equity of this change will depend on cultural and political factors as much as technological ones. Kurzweil believes that, by the 2050s, we may reach a point where $1,000 worth of computing power exceeds the capacity of the human brain by millions of times. This raises profound questions about the nature of consciousness and identity. As we rebuild our bodies and brains, leaving our natural biological limits in the dust, what will it mean to be human, or post-human? As we gain the power to reshape our bodies and minds at will, what will we choose to become? AI and the near future of work. What is the future of work in the coming decade, and how do we prepare for it? Without understanding the transformative power of artificial intelligence and automation, we could be wasting valuable time and resources trying to prepare for a world that won't exist. For over 2 centuries, technology has reshaped the landscape of production and employment. In the early 19th century,
you run 2
over
kilometers
80%
within
of
16
Americans
minutes
worked
and
in
19
agriculture.
seconds. Last
Today,
kilometer took you
that
8
figure
minutes.
is less than 1.5%. Manufacturing employment peaked at 27% in 1920 and has since declined to about 8%. Yet despite these massive shifts, overall employment and living standards have consistently risen, with new industries emerging to replace the old. Is the current wave of technological disruption different? Artificial intelligence and robotics are now capable of automating a wide range of cognitive tasks once thought to be the exclusive domain of humans. Self-driving vehicles, for instance, threaten to displace millions of professional drivers in the coming years. A landmark 2013 Oxford University study estimated that almost half of U.S. jobs were at high risk of automation by the early 2030s. As we look to the future, the potential for disruption becomes even more profound. By the 2030s, Kurzweil expects AI to surpass human capabilities in most cognitive tasks. This doesn't mean humans will become obsolete, but rather that our roles in the workforce will change fundamentally. We're likely to adapt by augmenting our own capabilities through direct interfaces with AI and other advanced technologies. Imagine having instant access to the sum of human knowledge, or being able to perform complex calculations as easily as you breathe. This human-AI symbiosis will redefine what it means to be skilled in the workplace. Education systems will need to undergo a radical transformation. Instead of preparing students for specific careers that may not exist in a decade, the focus will shift to developing adaptability, creativity, and the ability to collaborate effectively with AI systems. Lifelong learning will become not just a buzz phrase, but a necessity as the pace of technological change accelerates. In the meantime, this transition to new modes of work will present challenges for policymakers. The social safety net will likely need to expand to cushion the economic impact of technological disruption. We may see the evolution of Universal Basic Income, or UBI, or similar programs to ensure that people can meet their basic needs as traditional industries and roles become less central to the economy. Kurzweil believes that, by the early 2030s in developed countries and by the late 2030s globally, we could see some form of UBI providing a standard of living that would be considered comfortable by today's standards. Perhaps the most exciting aspect of this technological revolution is the potential for creating an era of unprecedented abundance. Exponential progress in AI, robotics, and nanotechnology is expected to dramatically reduce the cost of goods and services. By the 2030s, it may be possible to produce food, energy, and manufactured goods at a fraction of today's costs. This abundance could fundamentally alter the nature of scarcity and competition in society. Imagine a world where no one needs to worry about having enough to eat or a roof over their head. In such a scenario, the focus of human endeavor could shift from meeting basic needs to higher-level pursuits like scientific discovery, artistic expression, and philosophical inquiry. However, we must be cautious about assuming this transition will be smooth or happen automatically. The benefits of technological progress must be widely shared to prevent the exacerbation of inequality. In a world where traditional work may no longer be the primary source of identity for many people, there are questions of meaning and purpose we will have to grapple with. Moreover, this abundance won't manifest uniformly across all sectors at once. While computing power has become exponentially cheaper over the past decades, areas like healthcare have seen costs rise. Smart policies will be needed to ensure that the deflationary effects of AI and automation spread to essential services like education and medicine. As we stand on the brink of this technological revolution, our challenge is not just to develop these transformative technologies, but to harness them in ways that benefit all of humanity. The future Kurzweil envisions is one of unprecedented possibility, but realizing its full potential will require foresight, wisdom, and a commitment to shared prosperity. The main takeaway of this blink is that we're on the cusp of revolutionary changes driven by artificial intelligence, nanotechnology, and other exponential technologies. These advancements promise to transform medicine, work, and the very nature of human capabilities. AI is closing in on human-level cognition. Nanotechnology could dramatically expand our lifespans and cognitive abilities. The future workplace will likely involve close human-AI collaboration, requiring new forms of social organization and support. The road to the singularity is not a smooth, predetermined path. It's a journey that will require careful navigation of ethical, social, and technological challenges. But if Kurzweil's predictions hold true, the next few decades will be the most transformative in human history, ushering in a future that's difficult for us to imagine. Okay, that's it for this blink. We hope you enjoyed it. If you can, please take the time to leave us a rating. We always appreciate your feedback. See you in the next blink.